Early in the course, we took a look at how to solve linear inequalities. For example, something like this. 7x plus 3 is greater than 0. And we used some methods. We said it was basically like solving a linear equation, except for we had to be careful that if we divided by a negative number, we had to flip the sign. We had to flip from greater than to less than, or less than to greater than. But today we're going to look at how we can solve some inequalities that are a little more complex. Specifically, how would I go about solving an inequality with a quadratic in it? So for example, something like x squared plus 8x plus 7 is less than 0. What would the steps be for this? Well, to think about how we would need to go about to solve this, let's think about what it means to ask, where is this graph less than 0? Well, if I have a quadratic, and I'm not saying this is the graph of this quadratic, but in general, if I have a quadratic, and I'm asking where this value is less than 0, that's the same thing as asking is where is the y value less than 0, right? Because if I were to graph this, I would graph something like this, y equals x squared plus 8x plus 7. So when I ask where is x squared plus 8x plus 7 less than 0, the same thing as asking where is its y values less than 0. So in other words, if this were a picture of this graph, then I would say that this graph is less than 0 on this interval, right? Let's just say maybe this was like a -8, and maybe this was a -3. So I could say that this entire graph was less than 0 between x equals -8 and x equals -3. Now again, this is not the graph of this, but I'm just using this as an example. Perhaps these would be the points. And then I could go the other direction and say, oh, well, the graph is actually greater than 0 on these intervals, right? Where x is greater than -3, or where x is less than -8. In this particular interval, or these two intervals, the graph is above the x-axis. Its y values are greater than 0. So this is really interesting because we can see a few things here. First off, in order for a quadratic function to change from being positive, greater than 0, to being negative, it has to cross the x-axis. In other words, it has to equal 0 somewhere between being greater than 0 and somewhere between being greater than 0 and less than 0, right? If you're going to cross from being greater to 0 to less than 0, you have to equal 0 at some point because these graphs don't have any holes in them. They're continuous. Same thing from being less than 0 to being greater than 0. Again, you have to cross that x-axis. You have to hit a point where y equals 0. And then, if I look at this interval between where these points are equal to 0, where y is equal to 0 here and y is equal to 0 here, any point that I test on this interval should give me a y value that's all the same. So for example, in this example that I drew up here, every y value between these two numbers is negative, right? And then any y value on this interval, less than less than -8, they're all positive. And any y value here, greater than -3, they're all positive. So if you can figure out where the points are equal to 0, then you can just test all of the intervals around those 2 points, and everything in a particular interval should all be the same. It should either all be positive or all be negative. And this is the idea that we're going to use to solve an equation like this. If I can find where that, an inequality like this, I should say. If I can find where this is actually equal to 0, then I can test all around those points, all the intervals around those points, and everything within a certain interval should all be either positive or negative, and everything on another interval should either be all positive or all negative. So that means that I should be able to test any point in between these two values. For example, on this one I could have tested a point like -6, x equals -6, plugged it into my equation to see if the y value is positive or negative. If that y value is negative, that means every other y value in that interval has to be negative, because if it weren't, we would have had another 0 value, another point here, that would have split it up into more intervals. So this is the idea that we're going to work with. If I want to solve something like this, I should first find where the expression equals to 0, and then test a point in all of the intervals that are around those particular points. So let's try that. So I'm going to take this inequality here, x squared plus 8x plus 7 is less than 0. I want to find out actually where does x squared plus 8x plus 7 equal to 0. So if I set that up, well, I know how to solve this from past lectures, right? We could factor this into x plus 1 times x plus 7. And on this particular function, it looks like it equals 0 when x equals negative 1 and x equals negative 7. So we're not sure, well, actually on this graph, it's a little easier to tell because we know that it opens upwards. So we could maybe sketch it and draw it and find out where it's less than 0, where it's greater than 0. But there's a little different way that we're going to look at today. We're actually going to make a chart and just test all of the points that are on either side of these intervals. So if I'm looking at these 2 points, x equals negative 1 and x equals, say, negative 7 will be down here, right? And then x equals negative 1 will be right here. I can actually just test all of these intervals. So I can test the interval x is less than 7. I can test the interval that x is between negative 7 and between negative 1. And then I can test the interval where x is greater than negative 1. So let's look at these 3 intervals. And the general rule is that however many of these points you have, you're going to have one more interval. So we have 2 points here, we'll have 3 intervals to test. Now we do have a name for these. We typically call these critical points. So if you hear me make a reference to critical points, that's what I'm talking about, where the function actually equals to 0. So I'm going to take my intervals here. The first one is x is less than 7. The next one is x is less than negative 1 but greater than negative 7. And then the last one is that x is greater than negative 1. What I can do is pick any x value that are in these intervals, any of these x values, and test them. So for example, here I might want to test x equals negative 8. Here I might be interested in testing x equals negative 2. Greater than negative 1, maybe I'll pick x equals 0. That's definitely greater than negative 1. The idea is you want to pick test values that are really easy to plug back into this expression, because that's what we're going to do with it. I'm going to plug in negative 8 to this expression and see if that's a positive y value or a negative y value. Because if it's a positive y value, that tells me that everything in this interval from negative 7 down must be that same sign. So that's our idea. So I'm going to take these values, we'll plug them into x squared plus 8x plus 7, and we'll see what happens. So, and actually I'm going to do this a little more stealthily. Instead of plugging them into this, I'm going to plug them into the factored form of my expression, and you'll see why in just a second. It will make the computation a lot easier. So now if I plug in this to my expression, negative 8 into here, this will be negative 8 plus 1. That's going to be a negative 7. It's going to be a negative number. I don't care what number it is, I just care if it's a positive or negative number. And here the same thing, negative 8 plus 7, that's going to be a negative 1. So that will be a negative number. Well, we know that a negative times a negative is always positive. And so we know that anything in this interval over here should have positive y values. Okay, let's try another one. If I plug in x equals negative 2, I'll get a negative number here, right? Negative 2 plus 1 is negative. But negative 2 plus 7 is positive, so a negative times a positive will always be negative. So anything in this particular interval, all of the y values should be negative. Again, we don't care what this value is, we just care if it's a positive value or a negative value. Is it above the x-axis or below the x-axis? Now we plug in 0. 0 plus 1 is positive. 0 plus 7 is also positive. So we'll end up getting a positive there as well. So on this interval, everything is positive. So then the last step is just to ask myself, what is the original problem asking me to do? Well, it's asking me to find all of the intervals where this is negative. So on what interval is this negative? So I'll look over here at my chart. Well, on this interval, it's positive. On this interval, it's negative, so that's one I want to take. On this interval, it's positive, so don't care. So I'll say that this expression is always less than 0. It's always negative when x is greater than -7 and x is less than -1. And as you see, I could have probably graphed this and seen this anyway, right? If I graph this expression, I would have ended up getting a point here at -7, a point here at -1, and I would have gotten a graph that looks something like that. And you can see that makes sense with my chart here. The reason we do this with the chart instead of just graphing it is because when we get into more complex polynomials that aren't just quadratics, trying to graph it and figure this out becomes a little trickier of a situation. So it's nice to have this method that will work for any polynomial that we can factor. And so we might be using this a little later on whenever we have more complicated expressions. So let's just try a different one. How about the function y squared minus 4y is greater than or equal to 12? Now this only works when one side of the inequality is a 0. So we can't solve it just as it is, but I can move this around pretty simply and then just bring over the 4y, just bring over the 12 from the right, subtract the 12, and now I have definitely a quadratic equation, hopefully a quadratic inequality, hopefully I can factor this. So the first thing is I want to find my critical points. Remember, these are all the points where this expression is equal to 0. So I'll actually set this expression equal to 0 because we know that all the intervals that we need to test will come from these critical points. So this one factors pretty nicely. This factors into y minus 6 and y plus 2. So my two critical points are going to be y equals 6 and y equals -2. Now to find my intervals, it's really easy if you just sketch it on a number line. So here's -2 and here's 6. So I'm looking at this interval, y is less than -2. This interval, I'll use an x here, I should use a y, there we go. This interval is y is greater than -2 and y is less than 6. And this interval is going to be y is greater than 6. So let's test these to see where the positive and negative intervals are. So I'll be testing y is less than -2, y is in between -2 and 6, and then y is greater than 6. All right, we'll pick some test intervals here. So we just want to pick basically the easiest numbers that we can. Don't make your life harder than it has to be. So if you can pick things like 1 or 0, those tend to be the easiest. If not, pick the next best thing. Y less than -2, I'm probably going to pick a -3. Here, y between -2 and 6, I'm definitely going to pick 0. Because 0 tends to be really easy to plug in later. Y greater than 6, maybe I'll just pick 7. I'll pick the smallest number that I can. Now we're going to plug these into the factored version of this. So the factored version is y minus 6 times y plus 2. And then we're interested, again, not in the number that we'll get when we plug these values in, but just is it positive or is it negative? So -3 minus 6, that's a negative value. -3 plus 2, that's a negative value. And then a negative times a negative will always be positive. So anything on that interval will always be positive. 0 minus 6 is negative. 0 plus 2 is positive, and a negative times a positive will always be negative. 7 minus 6 is positive, and then 7 plus 2 is also positive, so a positive times a positive will always be positive. Now I can say, well, what am I actually looking for? We need to look back at our inequality here. And the inequality is asking where this is greater than or equal to 0. Now here we have to be careful because wherever y is less than -2, we know it's definitely positive, right? However, we're asking also where does it equal to 0, right? It can be positive or equal to 0. And whenever y is equal to -2, it's also equal to 0. The function is equal to 0. So I can include -2 in my answer. So this part of the answer will be y is less than or equal to -2. And then this also happens wherever y is greater than 6, we'll get a positive number, right? Greater than 0. But whenever y is equal to 6, we'll also have a function equaling to 0. So I can include that, and that's okay because of this greater than or equal to sign that I have here. If there weren't the greater than or equal to sign, then I wouldn't be able to include the less than or equal to and the greater than or equal to here. They would be strictly less than and strictly greater than. All right, let's try a couple more. So how about this one, t squared minus 5t. I'm interested to know where this is greater than or equal to 0. So if you look at this one is a quadratic, but it's easier to factor than we don't have to factor the trinomial, right? We can just factor out the t from the front, and we'll get t minus 5 left over here. So this tells me that t equals 0. Oh, actually, let's see. To find my critical points, I'm kind of getting ahead of myself. To find my critical points, I need to actually set this equal to 0, right? So to find critical points, let's say, where does this expression actually equal to 0? Well, it equals to 0 when t is 0 and where t is equal to positive 5. So these are going to make up my intervals. Again, I have 2 critical points, so that means I'll have 3 intervals. And if you want to find the intervals pretty easily, just graph them on a number line real quick, and you'll automatically have the intervals. So this is t is less than 0. This is t is between 0 and 5. And then this is t is greater than 5. So let's test these 3 intervals. So t is less than 0. T is between 0 and 5. And then t is greater than 5. These are the 3 I want to test. So I'll pick some test points. T less than 0, pick the easiest one you can, -1. It's probably the easiest one we can pick. T between 0 and 5, if you can pick 1, 1's always an easy one to check. T greater than 5, maybe I'll pick 6, that's the smallest number I can get. It's still an integer, it's greater than 5. And I'm going to plug them into the factored form of my expression. So -1, plugging that in for t, that's negative, right? So because it's a -1, and then -1 minus 5 is -6, so it's a negative number. So a negative times a negative is positive. Plugging in 1, I'll get a positive here, and then 1 minus 5 is negative. So a negative times a positive is always negative. Plugging in 6 for t, I'll get a positive, and then 6 minus 5 is also positive. So a positive times a positive is always positive. So again, I have to go back to my expression and ask and see what is it really asking. It's asking where is this expression greater than 0 or equal to 0. Well, it's definitely greater than 0 when t is less than 0, but it's also equal to 0 when t equals to 0. So I can include the 0 in my answer. So I'll put the less than or equal to. The other interval is when t is greater than 5. But this is also equal to 0 when t is equal to 5, so I can include the 5 in my answer, so I'll get t is greater than or equal to 5 for that particular one. All right, let's try one that has a little bit different outcome, just to show you some things you might see. So this expression, x squared minus 10x plus 25 is less than 0. Okay. Again, I'll just go ahead and factor this. This factors into x minus 5 times x minus 5 less than 0. So that's x minus 5 squared. So if I look for the critical points here, I'm going to set x minus 5 squared equal to 0. So I'll only get one critical point here, that's x equals 5. All right, so that means if I only have one critical point, then I only have 2 intervals to test. So I'll test x is less than 5, and I'll test x is greater than 5. Let's see what happens here. All right, so I make my chart. So x is less than 5, and x is greater than 5. Pick a test point. So x less than 5, pick the easiest one you can. I'm going to pick x equals 0. Greater than 5, maybe I'll pick 6. Okay? And then we're going to plug this into x minus 5 squared. Now this one's kind of tricky because, or not tricky, but interesting, because 0 minus 5 is negative, but then we square it. And anything that we square will always be positive. If you square a negative, it becomes positive. If you square a positive, it stays positive. So anything I plug in here is actually going to be positive. I don't even really need to check the values because I know I'm going to square it in the end. So it turns out here that I get a positive and a positive for this value. So I go back to my question. It asks, where is this function less than 0? Well, it's never less than 0. Every interval, it's a positive number. So I'll say that there's actually no solution to this inequality. Now, what does this mean graphically? Well, this means that this graph must have, it does have an x-intercept. It has x-intercept at 5. But it only has one x-intercept, right? So that means that the graph actually looks something like this. And you can see here the graph equals 0 when x equals 5, but the graph is positive everywhere else. It's above the x-axis. There's nowhere on this graph that the graph is below the x-axis. So that's why when we went to try to solve this, we ended up not getting anywhere where this function is negative. And so this is kind of interesting to see how this works versus the graphic solution, the chart solution versus the graphic solution. You could have figured this out either way. Let's take a look at an application of one of these types of problems. So let's say that maybe I'm shooting a model rocket into the air. When the rocket leaves the ground, it's leaving the ground at a speed of 256 feet per second. So that's the initial velocity. As it travels up into the air, it slows down, right, as gravity pulls on it, and it eventually stops and becomes falling, and starts falling and starts gaining velocity again as gravity is tugging on it. However, I'm interested in knowing, for some reason, I want to know at what time does the rocket above 960 feet. So maybe there's something to do with the air pressure or something like this. But I'm interested in knowing exactly how long or between what time intervals was this rocket above 960 feet. And the last piece of information that I have is that at any given time, the height of the rocket is given by this expression. So if you plug in a particular time here, you'll get the height of the rocket. For example, if you plug in time equals 0, you'll get that the height is 0, and that's because it hasn't left yet. So how would I use this to figure out this particular problem? Well, I'm interested in knowing if this expression tells me the height of the rocket at any given time. I'm interested in knowing when is the height of the rocket above 960 feet. Okay. That's the height I'm going to plug in. Now this just becomes one of the problems that we've been working all along, right? I can move over that 960, subtract it over, and now I'm just solving this inequality. Negative 16t squared plus 256 times t minus 960 is greater than 0. So we just need to solve this inequality now. And we know how to do this. Okay, so the first thing I need to do is find the critical points for this inequality by setting this actually equal to 0. So negative 16t squared plus 256t minus 960 equals to 0. So I want to know at what point is it actually at 960 feet, right? There's a split second. If you took a snapshot, there's a particular time that it hits 960 feet going up, and there's another time that it hits 960 feet on its way back down. So we should get 2 times out of this. Well, I can actually factor out the negative 16 here, and I'll be left with t squared minus 16t. And then I'll be left with a minus 60 here. And so this looks like a pretty difficult problem at first to factor, but after you pull out the negative 16, it actually becomes quite nice, because this will become t minus 6 times, I'm sorry, this should be plus 60. So this will become t minus 6 and then a t minus 10. This is what I'll get. Oh, there we go. Sorry about that. All right. So now we just need to figure this out. Well, this happens when time equals 6 seconds and when time equals 10 seconds. So in other words, again, if we were looking at our rocket, this is the 960 feet barrier. Then it would hit it on the way up at 6 seconds, and then it would hit it on the way down at 10 seconds. Now, we know that the rocket's going up, so we know that it's between these two time intervals. If we wanted to prove that this was the case, we could actually take these intervals and, again, throw them into our chart and say that, well, there's an interval where t is less than 6 seconds, there's an interval where t is between 6 seconds and 10 seconds, and then there's an interval where t is past 10 seconds. And we could pick some test values. So here I could maybe pick t equals 0, here I could pick maybe t equals 7, and here t equals 11. And we should get the results that we think. We should get that between 6 and 10 seconds, we get that it's greater than 960 feet there. Okay, so let's try this. I'm going to put this into the factored form, so negative 16 times t minus 6 times t minus 10. So if I plug in 0, well, that doesn't affect the negative 16, it will still be negative. But 0 minus 6 is negative, and then 0 minus 10 is also negative. So a negative times a negative times a negative is negative, which is what we thought. At this interval, t is less than 6, it's still below the 960 mark. Plug in t equals 7, we get a negative here, and 7 minus 6 is positive. 7 minus 10 is negative. A negative times a negative is positive times another positive. This will always be positive. Again, this is what we found with our diagram. And then when t equals 11, this will be negative. 11 minus 6 is positive, and then 11 minus 10 is also positive. We'll get that it's below 960 feet on those intervals. So the only one that actually works is this one, which is the one that we thought it would be from the very beginning.